Good morning. I'm Avrosh, and along with my friend and collaborator, Chris, we are talking about plugins that take audio in and produce MIDI out. We hope this will be a good talk for even beginners. We'll try to explain the concept so it's accessible. Right, a little bit about ourselves. I'm a research engineer at Pindrop. I'm part of the research team that researches human voice and its characteristics. We build tools to detect who is speaking from really short snippets of audio given a previous recording of your voice. Apart from that, I have background in music information retrieval, and I develop plugins, play guitar, and Chris.
Thanks. And I'm Chris Latina. I'm an audio engineer at Dolby. I've been working on spatial audio tools for about a decade. Also studied audio content analysis and MIR with Avrosh. And I work on compositions, especially using real-time feature extraction and feedback.
All right, so we've divided our talk into 4 phases. First, we'll talk about why do we want to produce MIDI from an audio track. Then I will talk about how do we do this. We will create a simple example of an envelope follower. Then it'll be a little show and tell of our plugin that we are developing called Flux. You'll see it in action that will demonstrate some of these ideas. And finally, it is a little bit complicated to map MIDI and use it in DAWs, and we will like to talk about some challenges. All right, let's get started. So first, to lay the groundwork, I want to just visualize our plugin API. We're very familiar with this. This is a process block. We have audio buffer, which can have input buses, output buses, multiples of them, where we represent our audio channels, which passes through the plugin. There's also a MIDI port, which provides us access to where we can write MIDI buffers to send the data out. Juice has abstracted a lot of differences in how different DAWs and hosts see these inputs and outputs from plugins using these very simple preprocessor flags. And we just have to configure what do we want in a plugin, and the hosts are eventually able to figure that out. So I will keep these in the bottom right corner, so keep an eye on that to see how some of the different plugins will be set up in Juice. So let's talk about a few standard types. There is audio effects, takes audio in, audio out. There are instruments that we drive using MIDI nodes, and they synthesize audio. There are also MIDI effects. A good example are arpeggiators that can take MIDI input, MIDI events, and transform them to either add or different harmonies to that. There are also plenty other types. There's music effect, which is very AU specific, which takes it in MIDI as well as audio. There are many other panners, mixers that act on multiple buses. But I don't want to get too much into it. I do want to mention that it's important to classify these plugins because we are building these tools for musicians and for producers. So it's good for these tools to be intuitive for them to understand what it is going to do. But the crux for talk is this type of plugin where we take a stereo input in, and we want to produce output as a MIDI. So we're trying to build a unit to extract some high-level audio features and output them as MIDI. So an example is a simple pitch detector where we can extract the pitch or chords and output them as MIDI in real time. But music is not just limited to melodies. There is timbre, mood, there's structure, there's rhythm in it, and these are all a function of time. They change over time as the music signal arrives, and there's a whole field dedicated to it. We heard some very interesting talks earlier about this that does audio content analysis and music information retrieval. These are the units that can extract information from the audio signal. And we can represent this information as what we would like to call a control signal and output it as a MIDI continuous control signals that can be very easily represented here. We can also threshold these control signals and produce events, MIDI events using that. And the reason we are doing this is so we can actually map these MIDI events to external devices, a synthesizer, DAWS, and actuate them. But we would like to go a little bit further into control signals, and for that, Chris,
Sure.
take it over.
So when Avrosh asked me to collaborate on this, we sort of wanted to take a step back and revisit some of our older work. I think around 2016, we had developed some of these concepts. And a lot of them stem from old modular synthesizers and some of their constructions, especially as modulation sources like LFOs. Eurorack is all based on control voltage. Super Collider has the control rate signal. Of course, there are automations in almost every synth and tool, Faust, more currently, Max for Live, Bitwig. So that was definitely the inspiration for this. In 2013, I developed an iPad app that worked to sort of hack NRPN MIDI for hardware synthesizers. Internally, some of them used NRPN to do, I think it's called, I don't know if it's modulation source, but it's sort of a real-time override and recording of the filter or the envelope on devices like the Electribe. So what I did was I would learn the NRPN MIDI and then allow the user to draw periodic signals like splines or LFOs and create banks of them, and then send them over MIDI so you could override and play existing hardware like a modular synthesizer. I think the classic inspiration is the external signal processor in the Korg MS-20. So this is such a genius design because you take an input in, you can extract the bandpass filtered version, which can be controlled by the low and high cut. You have a frequency out, which tries to basically figure out what the pitch of the incoming signal is, some CV offset adjustment, and a threshold level to set the hysteresis of your trigger output. And it also gives the envelope out of the signal, which is basically an envelope extracted level of the amplitude. And then itself with modular composition, routing is sort of the key to how compositions are developed with modular synthesizers. And in many ways, these wires that you connect the inputs and outputs of these processors, they become sort of the virtuosic element of playing the instrument itself. And also that routing becomes the structure of your composition. So the idea of using internal or external generators is sort of the classic technique to animate or affect sound. You can think of a flanger taking the envelope of the input and modulating delay lines, or a compressor, a VCA. Using envelopes and envelope extraction, you can create extremely dynamic and sort of expressive approaches to very simple signals, and they become very musical. This is very inherent in West Coast style synthesis with Buchla's envelope followers, especially feeding them back into the modulators and operators to create sort of unique structures. So with modern tools, we can now do audio content analysis, and we have a lot of information, even in real time, about the style of timbre, like Avrosh was explaining, about pitch and sort of more abstract semantics of a signal. And this is a quote I've used before in presentations, but I think it covers the idea so well. One of my favorite composers, Asmus Tietjens, he said, "Our recent digital and analog tools enable us to drive nearly every sonic event from nearly every other set of sonic events, and that tiny nearly constantly holds unexpected aural surprises." So in many ways, it's sometimes the portions of the algorithm that don't work so well that provide very interesting outputs for live performance or composition. These are some relevant pieces, thanks to Ryan Friedrich for tipping me off on the Smart Electronics KT drum trigger, which is a very similar tool to what we had developed. Takes in an audio signal, splits it up into 3 bands. You can tune the parameters, especially of the hysteresis, and it outputs a MIDI trigger. This is vocally a doubler, which is a real-time harmonizing vocal to MIDI harmonizer. And I think we will start explaining our tool.
Thank you. So let's come back from the modular world to our DAWS. And I want to talk about something that's very familiar, a simple sidechain plugin. It takes 2 buses, a sidechain bus, from which it extracts some parameter, and it tries to affect the original signal based on that. And there are compressors that do that. There are many effects that leverage the sidechain. What we can do with our approach is take that box out of that plugin and extract that control signal and emit it as MIDI, which allows us to control a plugin, but we can also control another plugin and extract something from that, do another, and many other, and create some interesting chaos that happy surprises that Chris was talking about. So let's build a quick envelope follower. And a note, an envelope following is trying to track the amplitude of a signal real time. So, all right, here's a get envelope function. We are providing it the audio buffer that we got in our process block in Juice. We're going to use a low-pass filter to do this envelope following. So we set our filter coefficients. At this time, we're only operating on the left channel. Based on whether it's the attack phase or the release phase, that is where the signal is rising or falling, we will choose a different coefficient. The different coefficient, and we'll apply the low-pass filter. In this case, we are looping over all the samples in the block, so I'm going to only capture the maximum level. So I will have 1 value of the envelope per block, but this is all totally up to you. We are going to decide the time domain resolution of our control signal, so we can capture a lot more values in this case and save them as MIDI events. Finally, for envelope following, you want low attack, high release for a nice smooth curve. Once we have the envelope, and the envelope position that is in the buffer, which sample was the maximum, we can send this to this function and write it as a control message where the value of the envelope can be scaled to a 7-bit control CC. Continuous control value. With MIDI 2.0, I'm excited we could go up to 32 bits, so we have even amplitude resolution. And we send this message. This is a simple visualization how the release, as you increase the release, you can shape the envelope. And we see as we go up to 100 milliseconds of release value, we have a nice signal resembling a sawtooth, kind of sync to the amplitude of our signal. We will like to present the plugin that we are working on that we call Flux, and hopefully we will play that. All right, so we have a plugin that we have dropped on an audio track, and I'm on a percussive track that you see on the left side. On the right side, these are the envelope being detected. Down here, I'm going to control the attack and release of this plugin to shape the envelope to get it to the stage that I like. So in this case, I want really sharp attacks because I'm working in percussion. Okay, so it seems I'm happy with the shape. Now I have another MIDI track on which I'm going to try and receive the MIDI that my plugin is outputting. So the MIDI monitor set up there, and now you can see the CC values are arriving here on channel 1. All right, what do we do with this? Let's play with the fan knob of our synth track, which is a completely different track, and map that CC signal to the panning knob. And we should start seeing the panning being affected based on our envelope of our signal. I've mapped it to the mute button and created a very cheap stutter effect with no effect plugin. All right, what else can we do? Let's bring a filter in and try to modulate the bandpass frequency. I can also set the range that I want to modulate in Ableton, so I can go from 80 Hertz to 8,000. This is a nice wah-wah effect, synced to the beat of my track. And of course, we don't have to limit ourselves. We can map multiple parameters to this control signal. We're approaching some chaotic regions. Let's dial down the resonance a little bit. All right. That was my attempt to show off a lot of things in 3 minutes. Thank you. So there's a lot going on, but let me talk about how the mapping happens. So live allows you to control any parameter using an external device like control surfaces. But if we want to do it from within our DAW itself, so we have to route our MIDI messages to a virtual MIDI bus so that live thinks that it's coming from outside. So to do that, we dropped our plugin on an audio track, which is now being routed to this other MIDI track, which is receiving the MIDI. And the output of this MIDI track is a virtual MIDI bus. And that's what makes it accessible. And finally, you quickly turn on MIDI mapping, select a knob, and you got your automation mapped to your CC control. Yes, there are challenges. It's so let's talk about how this VSTs and AUs will behave when they're trying to deal with MIDI outputs from a plugin. So to demonstrate one of the challenges, we have a VST version as well as an audio unit version of our plugin on different tracks. And you can see that the MIDI track only is aware that only the VST plugin is outputting the MIDI to this. So the MIDI coming from the audio unit is actually not even visible to our DAW. And Ableton does say that the audio plugin standard does not support MIDI, a direct MIDI output, and that's why we're probably not seeing that. So that means that DAWs that recognize VSTs are the only ones that can handle MIDI outputs, so we probably won't be able to use this kind of plugin in Logic, per se. But then that begs the question, do we want to tweak with the audio units API, or is it the hosts that need to handle this? So to explore that further, I was trying this in the Juice's audio plugin host, and surprisingly, audio plugin host actually does deal very, very well with this MIDI outputs. And I did some digging in the forums, and I found a 10-year-old patch from Lucas Z, and I even messaged him, and he said he doesn't even remember submitting it. but probably because of this, our Juice audio host actually does support that. So even after that, we look at these different inputs and outputs as these three style of tracks. That's how DAWs try to design it. You have audio track, instrument track, MIDI track. And it gets very challenging to route stuff around. And maybe, so I don't think we want to propose that we should open it all up and allow anything to be routed to anything. I don't think that that is really a solution, because this sort of classification allows musicians to intuitively understand what is this plugin or track supposed to do. And so it's more of a design challenge. We need to think of a user interface or user interaction, how we can make it easy to do this kind of thing. And that's why we think maybe an audio to MIDI could be a style of controller effects. And if we talk about these style of control signals being exposed from DAWS as a controller effect, maybe the hosts can actually expose controller tracks where it makes sense what is being mapped where, it's not just hidden away. Finally, closing remarks, we hope that this encourages more standards for hosts and plugin APIs to deal with MIDI outputs and control signals. And hopefully it also makes it easier for musicians and producers who work primarily with DAWs to do routing-based compositions that Chris was talking about. Thank you very much. You can contact us on these links. And please let us know if you have any questions. Thank you.
Hey, thanks so much. That was a great talk. I just had a quick question about how do you decide, what sampling rate do you go down to? Like in the example you gave, it was like the buffer size, but you might not necessarily always want to do that. Like, what have you found is the good standard for doing that for getting consistent experiences across buffer sizes?
I can cover this one. I think that with Modular, since you are operating an analog with FPGAs, you can have high resolution workflows. We chose a very kind of standard buffer size of 512 and are only extracting a single sample, low pass filtering it. I think it's up to the context of what you're trying to achieve. It can be low, it can be high. I know that MIDI CC resolution is 7 bits. I think MIDI 2.0, this will be very relevant because it's much higher resolution. Super Collider's control rate is 12 bits, I believe. So it varies. There isn't really a standard there. And I think it's dependent on the problem you're trying to solve.
And only thing I'll add is if you want a classic compressor, you want sample accuracy. So in that case, you would want the highest resolution from your control signal. But at this point, this kind of mapping will not really make any use of really high rate control signal.
And I think projects like multi-channel FPGA-based workflows really open up huge opportunities for this because you have high sample rate, you have parallelization. So the problems of threading and overloading existing workflows and protocols is sort of solved there.
Just a quick question about the routing confusions that happen with all the different hosts. Has it been considered, or is it just a real challenge to ship kind of just a wrapper MIDI driver for Windows and Mac so that it's oh, okay, we'll just pretend like we're a keyboard and now the user can just select? Or is that just such a mess to deal with that it's its whole other world?
I've tried it. So the first difference is between Mac and Windows. You could create a virtual MIDI. You can allow your plugin to create a virtual MIDI. But the thing is, the track receives a MIDI buffer which is synced to your time. But if you just start sending MIDI willy-nilly, so you don't have the concept of time anymore, so you have to schedule it if you're going to directly output MIDI to a random track. So it's possible, but is it worth it? We think that's why we think that it's more of a design problem that we need to approach it, that we want to think about control signals as something new instead of trying to retrofit it.
Yeah, and we also discussed even creating a virtual kind of MIDI matrix to solve this problem. And there are other solutions in other design contexts, of course, but it is a sort of open-ended problem.